What do you understand from a SDN? So you know that NSX-T is a SDN technology, right?
Yeah, SDN technologies. Yeah,
Right.
yeah,
So what is your understanding of a SDN? What is it?
yeah. SDN basically it's a control plane, data plane is separated. There is a SDN controller, and then there is a switches where we are programming, and then we are forwarding a traffic. So
Okay.
in this VMware SDDC, right? We have a there is also this is also SDN environment, but here they are using NSX as a controller. I think three controllers we can use it, and then uh, the host ESXi is the transport zone. So there is a that is also called as a edge, and then there is a tier 0 gateway, tier 1 gateway. It supports routing, security also, but I am focusing on routing only. So
Mhm.
it supports BGP, it support OSPF, it support multicast. So all those services are available. So yeah, it's about.
Okay. Okay. All right. So let us fine tune whatever we discussed till now.
Mhm,
Okay.
mhm.
So normally, so these are the servers. These are the servers.
Okay, okay.
This is a
Mhm,
switch. Okay. So I'm just giving
mhm,
a very fundamental basic information. Okay. So you know
mhm,
that when we go
mhm,
into production, this will not be a single switch. This will be multiple switch, maybe multiple layers. Correct. Okay. So I'm
mhm,
just for
mhm,
understanding, I'm just drawing one switch, and these are my
mhm,
servers, which is connected to these switches.
mhm, mhm,
Right. So these are my servers. This is my switch.
mhm,
Now
mhm,
I will have another three servers. So I'm directly
mhm,
going into the topic, okay, because you told you already have understanding of NSXT. Okay. So these are also servers. Now we will install NSXT managers. Right. So I have a set of servers where I'll be installing my
mhm,
NSXT manager. Okay. You told we can have three manager, and that is a recommended configuration also. Okay. So now can I run three NSXT manager on the same server? What is your opinion? Yeah, yeah. Vijay, my question is, can I install
mhm.
NSXT manager on the same server? What do you think?
What is your same server means?
In one server, I have ESXi
Mm,
installed, and
mm,
NSXT manager is a VM, right?
mm.
Can I run three separate VMs on the same server and run those VMs with a NSXT manager? Is that okay? What do you think?
Yeah, that is okay.
For a
That
production?
is okay because we should, in production is not good, but this is possible.
If you ask,
Correct
yeah,
or
if the question is,
uh,
can we do it? Yes, we
uh,
can do it, but that is not recommended.
yeah,
Right?
yeah,
We
not
will not,
recommend.
maybe for a lab or maybe for a testing we can do that, but not for
Yeah,
any
that is what
production
we have.
data.
Yeah, yeah. We
Right?
we are going to do.
So,
Yeah.
right. So first of all, the reason why we have three NSXT manager is for redundancy.
Mm, mm,
And redundancy means it at any point of time, NSXT manager
mm.
should not go down.
Go down. Yeah, yeah.
Right. If I run everything in on one server, single server,
It's a control
then
point.
what happens if that server crashes?
Correct, correct.
All the VMs will go down, all the
Mm.
manager will go down. So you will not have any control over the setup. So that is a reason it is recommended to run
Yeah, yeah,
NSXT
correct, correct.
manager on individual servers. So
Mm,
we need
mm,
three server.
mm,
Each server will be
mm,
running one
mm,
NSXT
mm,
manager instance.
mm,
That is clear, right?
mm. Correct, correct, correct.
Okay. And
Mm, mm,
it
mm,
is recommended to use
mm,
um, a configuration where it says these VMs should not be on the same server. Which case that will happen? If you have HA configured, ESXi, vSphere HA, if you configured high availability. What is high availability?
Mm-hmm.
If one server crashes, the VMs on that server will
Mm-hmm.
automatically reload into another server.
Another.
So if that feature is configured, then what will happen?
Mm-hmm.
If this server
Mm-hmm.
crashes, two VM will run on one server, correct?
Mm-hmm.
To
Mm-hmm.
NSX-T manager. That should not happen.
Mm-hmm.
Then the whole purpose of redundancy is gone there.
Mm-hmm.
So that is why VMware
Mm-hmm.
recommends
Mm-hmm.
to use a anti-affinity rule.
Mm-hmm.
Anti-affinity rule or anti-affinity rule.
Anti-abnetral.
F,
Okay. Okay.
right. So anti-affinity rule means
Mm.
affinity rule means what? Be together.
Mm, 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 mm.
Anti-affinity means don't be together.
Okay. Okay. Okay.
Okay. So in this HA cluster, we can configure that these three VMs should not be
Mm, mm,
together. That is the
mm,
anti-affinity
mm,
configuration.
mm, mm,
So when I
mm,
configure that anti-affinity configuration,
mm,
even if your host goes down, the VMs will
mm,
not be restarted on
mm,
another host where the other manager is sitting.
mm, 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 mm.
Okay, so if that should happen, then we need to have a spare server here, right? Then only if
Mm,
this server crashes, the VM will go to this side instead of going to the other side.
mm, mm, mm,
Okay, so these are the recommendations from VMware when you deploy
mm,
NSXT manager. Any
mm,
question?
mm, mm. No, no, correct. Okay, got it.
Right. So now what is the role of NSXT manager? NSXT manager is your control
Mm,
plane.
mm.
NSXT manager is your management plane. Okay. So NSXT manager will be
Yeah, correct.
acting as a control plane and the
Mm.
management plane.
Management plan. Okay, okay.
Right. So every configuration, every management, every monitoring, every troubleshooting, you will be doing it from your NSXT manager.
Mm, 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 mm,
Okay. And
mm,
all the functionalities of your network. So be
mm,
it switching functionality, routing functionality, or
mm,
any control plane synchronization functionalities,
mm,
all those will be controlled from the NSXT manager.
mm,
Okay.
mm,
All right. So now these all NSXT managers also will be connected to the same
mm,
network.
mm, 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 mm.
So what is the situation now? We have ESXi in that manager, NSXT manager is running, and we have
Mm,
ESXi servers here, which is
mm,
actually going to run your workload,
mm, mm,
right? And
mm,
this is also installed with ESXi. Can I
mm,
use any
mm,
other
mm, mm.
OS? Can I use anything else other than ESXi?
Uh, Anything other than ESXi? Uh,
We can. Okay.
yeah, this bare metal one. Bare
We can
metal
use bare metal, but not for workload. Bare metal for your edge node.
edge node. Uh,
Right. We can have KVM.
KVM. Yeah.
Yeah, KVM means it is a Linux machine.
Mm, mm, mm,
So we can have Linux with KVM installed. Like
mm,
ESXi, KVM is a
mm,
hypervisor.
mm,
Okay.
mm, mm, mm,
So we can have KVM and
mm,
newer versions of NSXT supports many other things. Even we can connect with the cloud also.
mm, mm, mm,
Right. Okay. So so this is how the connectivity will be. So simply
mm,
all these
mm,
devices will be able to talk to each other.
mm, 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 mm,
Correct. Obviously, if manager need to control ESXi or
mm,
KVM, he should be able to talk to him, and then only he can control them, right?
mm, 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 mm.
All right. So this is how the connectivity will be. Now we said
mm,
these all nodes will be running, or these all servers are used for running the workload. What is actually the workload we are using in data centers? Those all are VMs.
VMs.
Right. VMs will be running some kind of a database or web server or database server or something else. Right. So for NSX-T functionality or the NSX-T manager to control these all workload functionalities, they need to prepare these ESXIs for the NSX-T functionality. Or by default, when you install a ESXi on a server, he is ready for virtualization. He can run VMs, we can modify VMs, we can manipulate all other basic stuffs of VM functionality. But NSXT is far above than that, right? We can do network virtualization, we can do routing, we can do firewall, we can do load balancing, we can do many other stuffs. So how this ESXi will be able to do all those things? Because ESXi don't know about any of these functionalities. ESXi is not aware about NSXT capabilities. So what happens is from the NSXT manager, we will prepare these ESXi host to make him capable of these advanced features. How we make him capable? We will push some modules into these ESXIs. Okay, so we will install some VIB module. You know, right? In VMware, we are using VIB modules for softwares. So we will install VIB modules into ESXi. Now, what is these
Okay.
VIBs? These VIBs are softwares which is NSXT related, or it is part of NSXT. So now, once you
NSXT.
finish the installation, this host is now ready to understand the NSXT functionalities. Now we call him transport node, a host which is prepared or which is installed to get the NSXT capability. That node we call it as a transport node. Clear? So we can do the preparation on ESXi, we can do the preparation on KVM, but the procedure is different. Very slight variations will be there. Okay. So once these are uh, became transport node, they are capable of interacting with your NSXT manager. They are capable of understanding the NSXT functionalities like routing, switching, firewalling functionalities, all those things. Okay. Now we have another set of node which we call him as edge node. Edge node is also a transport node. Okay. So what is this edge node? Any communication from your inside data center to outside world will be through the edge node. Simply, it is like a node which is sitting at the edge of your data center. Okay. So if a VM running here, he wants to go to internet, some device he want to talk. Okay, then this will come to the edge node. From the edge node, it will be going out. Any traffic from the data center, NSXT enabled data center, it will go to the edge node, and from there it will be going out. That is the reason we are calling him edge node. Normally, we will not run any workload here because the whole data center traffic is coming to this. Already have a lot of load, right? So edge node, again, we will be preparing the edge node for NSXT functionality. And once he is ready, then he will be able to understand the NSXT, right, operations. Any question till now?
Yeah, fine.
Now the question is, what is the protocol we use inside our network to transport data from one node to another node, or one edge device to another edge device? When I say edge device, it is not an edge node. Edge device means it's a VM, okay, or a workload VM. So if this VM wants to talk to this VM, what is the protocol or what is the transport protocol inside your network?
One VM to VM to
Another VM.
VM. Ah.
Yeah. So forget about the NSXT. In a traditional network, what is the protocol we are using to communicate?
TCP,
We are using TCP, or
TCP/IP
we are
for
using
transport.
UDP, right? Or we are
UDP.
using RTP, right? So like that,
Mm-hmm.
we have multiple protocols. So when it
Mm-hmm.
comes to NSXT,
Mm-hmm.
what protocol we are using?
Here I will be using VXLAN, VXLAN or
VXLAN, right?
okay, okay.
Okay. So again,
Mm.
what is this VXLAN doing here? So when I use VXLAN, do we need to throw the old switches and purchase new switches which is capable of VXLAN?
For VXLAN, right? The software, right? Here we have a software, but uh, no, actually, VXLAN is for transport. This for data path. So old switches we can manage it.
So what the old switches will be able to understand VXLAN?
No, that VXLAN packet, right? Um, that Nexus will understand. Cisco Nexus will understand, but
So
the
how about I
uh,
have a traditional data center with the old switches, no Nexus
that will
switches?
not understand.
That
But
will not
basically, if
understand.
you encapsulate and send that will understand, right? But old
So
switches,
so my question is, when I use NSXT and NSXT is
uh,
using VXLAN, can I use the
uh,
old switch or I need to purchase new switch? That is my question.
NSXT using a VXLAN means you have to you buy new switches only.
By new switches, right?
Mm,
Okay, so this we will discuss. Okay, so
mm,
what is the
mm,
logic behind the NS VXLAN and the old and new switches?
mm,
See, we
mm,
have different type of SDN products
mm, mm,
or
mm,
different vendors. They have their own
mm,
SDNs.
mm,
One is
mm,
Cisco, right? What is the Cisco
mm.
SDN? ACI,
That is a epic. I see. Yeah.
right? ACI is the Cisco SDN,
Yes, this question. Yeah. Yeah.
and NSXT is the VMware SDN.
Mm. We have understood.
And there are many other vendors. They came up with their own SDN products.
Mm, 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 mm,
Okay, so now
mm,
depends on which product we are using, the
mm,
answer for my question will come different.
mm,
Okay, so if you are thinking about Cisco ACI,
mm, mm, mm,
then the answer is throw out all your existing infrastructure, networking infrastructure, and purchase new
mm,
set of infrastructure
mm, mm,
to enable SDN on your network. Okay,
mm, 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 mm,
but if you are thinking about VMware NSXT,
mm, mm,
whatever
mm,
traditional old useless switches you have doesn't matter. On
mm,
top of that, you can run NSXT. You
mm.
don't need to change any of
Mm.
your existing infrastructure.
Oh, okay. Okay.
Okay, so these all
Why?
different. Sorry,
Why? How?
I'll come to that. I'll come to that. Okay, so these are the different uh, points a design engineer or an architect will consider
Mm,
when they decide on which product they want to go and how, what is the costing, and many other things they will
mm,
consider. Okay, see,
mm, mm,
if you have an existing data center
mm, mm,
and company don't want to spend more money on infrastructure,
mm, mm,
and
mm,
they are not too much concerned about the performance, okay, then they can go with the NSX-T on an existing infrastructure. Clear? Now coming to your question, how come, right? We are not replacing the existing hardware. Or what about VXLAN? What happens is your VXLAN encapsulation and decapsulation will happen on your servers, not on your switch. And when a TCP IP packet comes in, he will encapsulate it inside a VXLAN header, and on top of that, Ethernet header will be there. And normal switches, they understand Ethernet, right? So by looking into Ethernet, it will go to the destination. Once it reaches the destination, this host, he will remove the Ethernet header, he will remove the VXLAN header, and the TCP IP packet will go to the VM.
The server will do.
Server will do. That is why we are doing this preparation. Transport node preparation we are
Okay.
doing, right? I told we are installing some VIPs. This VIP software is
Correct.
capable of doing
Correct.
this VXLAN encapsulation and decapsulation.
Correct. Correct. Correct.
Clear?
Okay. Uh,
Am I making things simple
okay.
and clear, or you are getting confused?
Yeah. 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 Clear. Clear. Clear.
Okay, fine.
Yeah.
Now coming to the other part. So if a company wants to make their data center at very high performing level, they don't want any delay in performance. They are not concerned about the cost. Then they can go with a Cisco ACI. So we are removing all the existing hardware. We are putting a new set of hardware which is capable of doing the VLAN, VXLAN encapsulation at the hardware level itself, at the switch level. So obviously, a function done by a software and hardware will be, there will be a difference in performance, right? So Cisco ACI does everything at the hardware level. Obviously, the performance will be better.
Better now.
Okay. Now another combination. Nowadays, organizations are installing their data centers with Cisco ACI and NSX-T on the same data center. So what is the benefit there? So the problem with ACI is we have something called a spine leaf topology. Okay. Now your VXLAN functionality is here. Your controllers are connected here. Okay. And these controllers can control all the activities in this area, network level. But how about your servers? How about your VM networking? We don't have control. Okay. So there comes the NSX-T part. So if we install ACI, we are getting high performance and SDN functionalities, single pane of control or whatever blah blah we are talking about in SDN, we will get here. But at the server level, VM level, virtualization level, we have very limited access. So what we do, we will deploy NSX-T also on this. What is the benefit of NSX-T? I have very minute deep control on my VM level functionalities. For example, if I tell you NSX-T firewall, okay, if I have a VM with two NIC card, this is NIC card 1, this is NIC card 2, okay, it is connected to my server's virtual switch, right? vSwitch will be connected or DV switch. There is a firewall per NIC in NSX-T. Okay, there is a firewall on the first NIC, there is a firewall on the second NIC also. So that much of minute control of functionality you will get. So that means from a VM, when the traffic goes out, before it hits to the distributed switch, NSX-T can decide whether this traffic should be permitted or not. But how about
mm,
ACI? If you don't have NSXT, the traffic will
mm,
pass from this VM to this server, then it will
mm,
go to the leaf, and here the decision will be
mm,
taken.
mm,
Right.
mm,
So
mm,
within
mm,
my VM or within my host,
mm,
if I have multiple VMs, we cannot restrict, we cannot control them.
mm.
The host level restrictions
Hello, can you
are very limited.
can you can you repeat without NSXT?
Without
Uh,
NSXT, if I have a VM,
mm,
if you want to
mm,
talk to this VM, traffic will go
mm,
from this VM to the ESXi, from the ESXi to this
mm,
leaf, from the leaf to the spine,
mm,
spine to other leaf, it
mm,
will come to here, right?
mm,
And where is the restriction
mm,
happening? On the leaf. Policies are implemented on the leaf.
mm, mm,
So the
mm,
traffic will go up to here.
mm,
Then only restrictions applied. But what happens if I have two
mm,
VM? They are talking to each other.
mm,
Can I control it?
mm.
There is no firewall functionality.
Yeah,
Firewall functionality is here, right?
yeah, 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 yeah. Okay, 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 okay.
That level of control
So,
NSXT will give you, because all
mm,
your firewall, routing, NSX, there's a load balancing, every functionality is in your host. Within
mm,
the host,
mm,
you can do all the restrictions, all the control.
mm, mm, mm,
Fine. So nowadays, if you
mm,
see in the production, you can see a lot of
mm,
deployments with Cisco ACI plus NSXT.
mm. Oh, both are
Yes,
different,
on the
deployed.
same data center, both together.
Mm.
So you will get maximum
Oh,
performance,
together.
and you will get the
Uh,
ultimate control on the functionalities also.
mm, okay, okay.
All right. So now, okay. So any question till now?
Yeah, fine, fine, fine.
Right. Now we'll just go back. Okay, we'll discuss some fundamental things, small things.
Yeah.
Okay.
Mm,
We are going with SDN.
mm,
So why we are going with SDN? What is the issue with the traditional data center?
mm. Scalability.
Scalability, scalability in terms, can you explain it? Even traditional data center also, I can add more servers, I can get more VMs. It is scalable, right?
No, in case of SDN, right, you can expand more with the software and servers. In traditional, you need to buy more hardware. It will be costly, right?
More hardware in the sense, which hardware?
The routers or switches for connecting the data centers or servers, right? Within the data center or in between data centers, you need to buy more hardware in a traditional data center.
Okay,
But
okay,
in
we'll come
case
to
of
that.
SDN, right, there will be a controller and then you can buy host or
Mm,
machines, servers only.
okay,
Less investment and more like more software, more servers we can have it.
right.
You can have
What
more
else?
functionality in softwares.
Mhm. What
One
else?
is a cost, another one is a lot of features will be there in SDN. Traditional doesn't
Okay.
have any
Cost, features,
cost.
uh, hardware. Okay.
Yeah,
Scalability.
technology wise,
Okay.
there's a control plane, data plane separation, right?
Hmm.
So, uh, so the data path is separate, right?
Hmm.
So we can send a lot of traffic because
Hmm.
data traffic will be go in the this one, right, flow switches or data switches. So the
Okay.
routing table update will be less in terms of SDN, very less,
Hmm.
but in traditional frequent routing table update will be there.
Okay.
routing table update, and then your data traffic will be more once it's land in the control plane, right, and the routing done. We can use this forwarding path for all sending in
Mm,
traffic in terms of SDN. But in
mm.
traditional, right, uh, it'll be the routing table update will be more takes
Right.
more traffic as well. Yeah.
Okay. Okay. So we'll discuss few things here. Okay. So assume this is my servers, this is my
Mm,
access layer, and this is my
mm,
distribution layer. And
mm,
from the distribution, I have the external routers, right? Outside world connectivity is there.
mm,
This is internet one, this is internet two. Okay.
mm, mm, mm,
Diagram is clear, right?
mm, mm, mm,
This
mm,
is my access layer,
mm,
two pairs. This is
mm,
another access pair, two layer. Hmm.
mm, mm,
Now I have my servers, VMs are connected here.
mm,
Assume that this is
mm,
on network one, subnet one. This is on subnet two,
mm,
two VMs on the same host.
mm, mm, mm.
How this VM1 and VM2 will communicate?
Subnet 1, subnet 2 with some router.
So
Gateway should be
that
there,
means
external gateway.
uh,
Yeah.
that means the VM traffic will go to the host, from the host to
Mm,
the
mm,
access
mm,
switch to the
mm, mm,
distribution. Normally
mm,
distribution switches will have the gateway, right?
mm,
Then the
mm,
routing
mm,
will
mm,
happen. Then it will again come
mm,
back. Again it will go to the
mm,
same host, then to the second VM. Correct.
mm, correct,
So
correct, correct.
the traffic is going on one way, and on the same
Mm,
way it is coming back. But
mm,
where is the
mm,
source and destination? It is very adjacent. Correct.
very adjacent.
This much
Yeah.
of travel is unnecessary.
Mm,
So this is one problem we face in traditional data centers. This is what we call it
correct.
as
Mm,
hairpinning problem.
mm.
Okay, unnecessarily traffic goes like a lady's hairpin is there now. It is similar to that only, right? Traffic goes coming back on the same path,
Mm.
right?
Yeah,
This is
correct,
called
correct, correct.
hairpinning problem. This is
Mm.
actually degrading our performance. No, unnecessarily it is going. We are using
Mm,
our bandwidth. We are using our CPU,
mm,
memory, right? Finally, it is coming back to the
mm,
same place only. Okay. So
mm,
this is one problem.
mm,
Second,
mm,
in traditional networks, this switch, if I
mm,
need to manage, I will log into this. I will do all the
mm,
configuration, right?
mm,
And I will go to this switch. I will do all the configuration. I'll do all these
mm,
devices. I will configure individually, separately, no relation.
mm, mm,
Now assume
mm,
that
mm,
at the end, something is not working.
mm,
Where you will check?
mm, mm,
You need to log into every device and see what configuration, where you made a
mm,
mistake,
mm,
right? You need to do
mm,
comparison or do tracing, lot of things. Is another problem,
mm,
right?
mm,
Now coming to the third problem.
mm,
If my customer, assume this is a data center, okay? It's a service provider data center. I have a customer X. He says I need a dedicated, isolated communication, isolated network. Y says I also need a dedicated communication. So what they need to do? They need to go with a separate set of physical switches, routers, firewalls, load balancer. Everything should be individual, separate. So cost is more. That means the hardware is more, right? 3 and 4 is similar, dependent. And coming to the features, if you are a traditional data center user, you are having a data center and routing, basic routing and switching are the capabilities. Anything else, you need to purchase extra features. Feature means your firewall feature, load balancing feature, or any other security feature, right? Anything you need to spend extra. So these are all the problems of your traditional data center.
Yes, correct. Yeah, yeah. Mm,
Fine? Anything?
mm. Yeah, yeah, yeah.
So coming to the scalability. Scalability means
Mm,
how many how to say, for example, in traditional data center, how many
mm,
networks you can create? Each network will be part of one VLAN, right?
mm, mm, mm,
So what is the limitation of VLAN? 4094, right? So you can have maximum of
mm,
4094 customer over.
mm.
So it's a restriction. Okay. So these all are different, and scalability we can think in another way also. When I keep adding more devices or VMs, my headache is increasing. That is inversely impacting the scalability, right? So when a small change happens, we need to worry too much where I'm going to screw next, right? So these all are the problems with the traditional data center. Now let us see how these all problems are rectified by SDN. As we discussed just before, okay, assume this is a NSX-T deployment. Okay, we have NSX-T deployed here. We have controllers, 3 controllers, and these hosts are NSX-T ready. Now, same scenario. My VM1 on subnet 1, VM2 on subnet 2, they want to talk to each other. How the traffic will happen? The traffic will go to the ESXi. Routing will happen here. Why? Because we have logical routers in NSX-T, which is running inside your ESXi's. So he will do the routing and traffic is forwarded to the destination. So there is no hairpinning. So this problem solved.
So the routing done inside the NSX, it will not go to leaf switches
It will
or
not
distribution
end
switches.
end devices, end device traffic. I'm talking about the workload traffic.
Mm,
Okay.
mm,
So workload traffics are routed inside your
mm,
hypervisor itself.
mm, mm,
Okay.
mm, 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 mm,
So if my
mm,
source and destination on different hosts, then the story is different because we don't have any other alternate way. We need to follow the physical
mm,
path only, right? Traffic will come to
mm,
the host, will go to the access switch, go to the distribution, will go to the other switch, and we don't have any other choice. But
mm.
again, routing is not happening here. Routing will happen here only.
Okay.
Okay. So
Okay.
always routing will happen at the hypervisor level.
Mm,
So
mm,
hairpinning problem is over.
mm,
Now coming to control plane and data plane thing. What I said previously,
mm,
if I need to
mm,
configure my devices, I need to log into each and every device, configure it, and break my head and find out where is the issue. Now in NSXT, what happened? We removed the control plane from the
mm,
devices. And where is it? It is in the manager or the controller.
mm, mm,
Now, whatever you want to do, you will log in here. That's it. Every other device, part of your SDN, can be
mm,
configured, managed, monitored from this managers, NSXT manager or NSXT controllers. Clear?
mm, mm,
So you log in into one place and you can
mm,
click on individual device and you can see what is happening on that device. No need to log into individual devices and see
mm,
what is the problem.
mm, mm,
And most of
mm,
the time, you will have alerts created
mm,
in the manager itself. You need not to dig too much. You log in, you will see
mm,
some red color.
mm,
Click on
mm,
that, you will be able to identify the issue and you can resolve it most of the time.
mm, mm,
So your configuration, management, troubleshooting, everything became easy.
mm, mm,
Fine. So that is the benefit of removing your control plane from your individual devices and put into a centralized place. So when I say removed control plane, it is not 100% removal. Majority is right moved here, but there is a small portion of control plane functionality still lies on individual device. Okay, so that problem solved. Next, coming to the cost and hardware. In SDNs, depends on what SDN you are using. For example, we are talking about NSX-T. NSX-T bundle itself have firewall load balancer, right, and the packet analyzing and many other capabilities. So these all, if you are using a traditional data center, for each customer you need to purchase individual hardware. Now in NSX-T, when a new customer come in, what we will say, deploy a firewall, done, just a click, no additional cost, no additional hardware, no power cost, no cooling cost. And when we add more hardware, heat will be produced more. We need more power. We need more cooling systems, ACs. All those things we don't need here, right? And features also feature rich. NSX SDN is feature rich compared to the traditional data centers. Scalability. You add, remove, or whatever you do, everything you are doing from the controller. So it's easy for a admin. For example, if you look at the traditional network management, whenever you add some new host or something, we will make entries in the routers, ACLs, right, or firewall access list roles. But when we remove that particular resource, normally we will not touch that ACL. Why? Because we are not sure who created that rule, for what purpose that rule is created. If I remove that rule, any other device will go down, communication will block or not, we are not sure. So most of the time, if you see on enterprise devices, there'll be a lot of stale entries. That means useless, which is not used. Maybe we used once, we removed the resources, but still those rules are still running on the devices, right? So nobody is dare to touch those configurations. But when it comes to SDN, when you configure a device, those configurations will be pushed to the corresponding networking device. When you remove that end device, all the rules of that corresponding device will automatically will be removed from the network. You need not worry about it. Okay. So it
Okay.
is like on demand. Your network will be prepared for your resources, whatever you connected. Is that clear?
So you told 5 points, right? First is air pinning. Second, what you are saying, I want to
Second
reply.
is the network management configuration, all those
Mm.
right day-to-day task
Okay.
is difficult.
Okay. Okay.
That is
Difficult.
rectified by
Mm.
right making a
Mm.
centralized management plane, a centralized
Mm.
management
Mm.
control plane
Mm.
functionality.
Mm.
Any question?
Yeah. Yeah. Fine. 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 Yeah. Thank you.
Right. Okay, so just today we were expecting more
Mm.
candidates. Maybe they are stuck in some other things.
Mm.
Okay,